Hi, we're on 11.02 today for Algebra 2, continuing on our unit with sequence and series stuff. So today we're going to talk about geometric sequence and series. And we're actually not going to talk about recursive quite yet. We're going to save that for next time. So this is just geometric sequence and series, where last time we talked about arithmetic. The difference between them is instead of adding something to get to the next number like we did in arithmetic, we're going to be multiplying by something to get to the next term. So think multiplication when you see geometric, and think addition. Arithmetic starts with an A, addition starts with an A. Think addition for arithmetic, multiplication for geometric. So a geometric sequence means you have a common ratio. That's the number that you're multiplying the previous number by to get to the next. And a series is the sum of all the terms of a sequence. So you'll see plus signs between the numbers instead of commas. On the reference sheet, you're given both the formula for a single term and for a sum in these two boxes. You see those right here. For the single term, a sub n, that's like your nth term. So if you're looking for the fifth term, it would be a sub 5. A sub 1 represents your first term. R is your common ratio, which we just talked about up here, which is what you're multiplying by to get to the next term. And then n is whatever term you're on, minus 1. For the sum, this one is a little bit easier than the arithmetic sum because you don't need to have the last term to do it. You just need to know the first term, the common ratio, and how many terms you have that you're talking about. Now I put 2 on here. This is the one that's on the reference sheet, but I find that this one is a lot easier to use. Now they're the same thing. It's just that in this one, your a sub 1 has been factored out. So see on the top right here, you have a sub 1 written twice. We're just taking that out as a GCF right here. And you're left with 1 minus r sub n. So if you a1 divided by a sub 1 is 1, and then this term divided by a sub 1 would leave you with r to the n. And this just helps us a lot because sometimes we're looking for a sub 1. So I tend to write this one out when I'm doing these problems. But feel free to use that one as well. So you don't have to memorize it or factor it out. Okay, so number 1 says find the common ratio. So just like we did with arithmetic, we're going to take the second term and the first term, but instead of subtracting them, we're going to divide them since we want to know what's being multiplied by each term to get to the next. So I'm going to take negative 3 divided by 6 gives me negative 1/2. Okay, so that should work no matter what terms you take too. So it doesn't always have to be the first and the second term. That's just easiest for what we're starting out with. And then double check it. So check that 3/2 times negative 1/2. That's going to give me negative 3/4, and that checks. Okay, so that's finding the common ratio. Number 2 says find the 11th term. So we're looking for a specific term for the sequence. So we're going to use our term formula, which again is given in the left box or on the reference sheet as well. And I'm looking for the 11th term, so n is going to be 11. I can tell here from this sequence that's written out, a sub 1 is 1. I need to find my common ratio. So to find my common ratio, I'm going to take my second term, divide it by my first, gives me negative 1/2. And we found a sub 1, r, and n, so it looks like we have everything we need. So a sub 11 is going to equal my first term, which is 1, times my common ratio, which is negative 1/2. And since that's being raised to an exponent, It's extremely important that that goes in parentheses with the negative, raised to the 11 minus 1. Now at this point, you can just type this whole thing directly into your calculator. Be really careful that right now it's a 1, so it's not going to change anything, but this can get tricky if you try to do it in your head. So let's just practice typing in our calculator. So 1 times, in parentheses, alpha y equals, I've got negative 1 over 2, close my parenthesis, and then raise to the 11 minus 1, or just 10. Okay, let's see, does it change it for me? It does, into a fraction. If it didn't, then I would want to do 2 to the 10th power on my own to see what it would give me. So let's just rewrite it out. A sub 11 is 1 over 1024. So that's how you find a specific term in a geometric sequence. Next up, find the sum of the first 8 terms of this sequence. So now we're going to use our sum formula. So S sub n equals A sub 1. And again, I like to use that first one. So I factored out my A sub 1 from the one that you're able to memorize. And let's just list out everything we're going to need here. So n, we know we're looking for the first 8 terms. So n is 8. A sub 1 is my first term, which is the first one listed, so negative 5. I need to know my common ratio, so I'm going to take second term divided by the first term, gives me negative 3. Again, you could do that with any 2 terms, dividing them to get the common ratio. And we have A sub 1, we have R, we have N, so that should allow us to find the sum of the first 8 terms. So S sub 8, our first term is negative 5. 1 minus my common ratio is negative 3 raised to the 8, all over 1 minus my common ratio of negative 3. So when it's addition and subtraction, you don't need those parentheses. So these the hardest part about these is simplifying and all these negatives, because down here, we can make those double negatives into a positive. But right here, and this is the part that really is tricky, you can't make those the double negative into a positive, because this negative 3 is being raised to the 8th power. And with order of operations, you have to do exponents before you can do your addition or subtraction. So you have 2 options. You can do your order of operations yourself and raise negative 3 to the 8th power first, or you could type in this entire thing into your calculator at once. So that is up to you. Probably the calculator is going to be the least risky. So let's see how that comes out if we type it in. So we've got alpha y equals, and we've got negative 5, parentheses, 1 minus, and I need to have those parentheses. If I don't, it won't come out right. Negative 3 to the 8th. Oops. Close that parenthesis, over 1 plus 3, or I'm just going to put in my 4 for now, but I didn't have to, and I get 8,200. Okay, if I wanted to do it separately, I would have typed in negative 3 to the 8th here, and then put that in. So I'll show you how to do it that way as well. So, or you could have just said, okay, 8,200 is my sum, and I'm done. Now, S sub 8, and I know this stuff does come up on like SAT stuff, so we want to make sure you understand how to get these and calculate them for that SAT as well. So this would be 6,561 over 4, and then simplify. So negative 5 times negative 6,560 over 4, and then again, you can type that into your calculator, get 32,800 over 4, which would give us 8,200. But again, you can just type this whole thing right into your calculator. Even if you did 1 minus negative 3 in the bottom, that would also work. So as this sequence continues, forever, then the sum of those first 8 terms would give us 8,200. Number 4, what is the first term of a geometric sequence if the common ratio is -2, so I know r is -2, and the sum of the first 6 terms is -105. So S sub 6 is -105, which means n must be 6 if I'm looking at 6 terms. Since I'm given that what the sum is, I'm going to start with my sum formula. Because if I look at my term formula, I would need to know I need to know like the nth term, so the 6th term, which I don't know. So S sub n, a sub 1, 1 minus r to the n, over 1 minus r. Okay, so now in for S sub 6, I'm going to put my sum of -105. And my first term I'm looking for, I don't know. 1 minus my common ratio. Again, this is a negative, so it has to go in parentheses because it's being raised to the exponent of 6. And 1 minus -2, when we're adding and subtracting, it does not need to go in parentheses because that would just become our double negative. So now I'm going to kind of start to simplify here. Again, be very careful here. You cannot, I repeat, you cannot change this to 1 plus 2 to the 6th. -2 is being raised to the 6th power. You have to do exponents before you do your addition and subtraction, so you cannot change that sign. But what I can do is I can type in -2 to the 6th into my calculator. And that, since it's an even exponent, is going to give me a positive number, 364, which is why we can't just do minus a negative, because you guys would have had 1 plus 64. All right, now let's put -105 over 1, and I'm going to cross multiply. And I get -315 equals a sub 1 times 1 minus 64 gives me -63. And to solve for a sub 1, I'm just going to divide both sides by -63. And a sub 1 is 5. So my first term would be 5. So it's just a matter of using those formulas and substituting in. Number 5, how many terms are there in a geometric series? If the first term is 3, the common ratio is 2, and the sum is 93. So this time I'm being asked how many terms, which means I'm looking for n. So I want to find n. My first term, a sub 1, is 3. My common ratio is 2. And my sum of however many terms, so n terms, is 93. Because I don't know how many terms, that's what I'm looking for. Again, since I'm given the sum, I'm not given the nth term, I want to start with my sum formula. So a sub 1 times the quantity 1 minus r to the n, all over 1 minus r. Let's sub in what we know. S sub n, we know the sum of the n terms is 93. We know the first term now is 3. We know our common ratio, or r, is 2. We don't know n. And we know again r is 2. So let's simplify here. So we've got 93 equals 3 times, nothing we can do to simplify there yet. 1 minus 2 though, that's -1. So I can multiply both sides by -1 to get rid of that, or just divide up even, or if you wanted to, you could also put 93 over 1 and cross multiply. Either way, a lot of you can probably just do that right in your head, or you might have divided up. Either way is fine. The reason I'm showing to you this way is because if this were a different number, so let's say it was a 2 in the bottom or 5, you wouldn't be able to just divide up into the 3. So I'm just preparing you for one that you'll see on your homework where it's not going to be a -1, so you'll want to cross multiply for that one. All right, so now we have a nicer equation, but we're trying to get that solve for this n over here. So let's get rid of this 3. So divide both sides by 3. So we get -31. These cancel, equals 1 minus 2 to the n. Again, we're trying to get this n by itself here. So I'm going to subtract 1 from both sides. Get negative 32 equals negative 2 to the n. So another tricky part right here, because these negatives, especially with exponents, tend to throw students off. So I'm going to rewrite this in a different way. What this is really saying, because this negative is not in parentheses, it doesn't look like this. That's not what we have. The negative is outside the parentheses. So the negative is not being raised to the nth power. Just the 2 is right here. So really this is like negative 1 times 2 to the n. So now I can divide both sides by negative 1, leaving me with 32 equals 2 to the n. And here, and this one's a little easier one, but we want to solve for our exponent. So our variable is in the exponent. What are we going to need? That's right, I heard you yelling it. We need logs. So you have two options at this point. You can either rewrite it, and you guys are kind of split as I've been grading your work, I see. You could either rewrite it as log base 2 of 32 equals n, and then use your alpha window, choice 5, I believe it is, alpha window, choice 5, yep, to type that in to get your answer. Or you could take the log of both sides and have log of 32 and then swoop to the front. So it'd be n log 2, divide both sides by log of 2. And either way, you're going to get 5. So that would be if we had 5 terms for that one. I know I kind of ran out of room here. But if you have any questions on using the logs or solving that, most of you seem pretty good on your test. So if you do need help on solving that, let me know. And I can go over that a little more detail with you and give you a couple practice as well. Okay, and that is it for today. Hope you guys are all doing well, staying healthy. I miss you. Hope you're maybe learning a new math dance to teach me. And I hope to see you guys soon. Bye out.